All this week in pre-calculus, we're going to be working with radians inside the unit circle. Radians are the preferred measurement over degrees in calculus. So what is a radian? How does it relate to degrees? How to convert back and forth between radians and degrees? This video is just a very basic introduction to radians. So in the unit circle, an angle of 1 radian, so a radian is a way to measure an angle, is defined to be the angle in the counterclockwise direction at the center of a unit circle which spans an arc of length 1. So the key part that I would like you to pull out of this definition is that a radian is a way to measure an angle. So in the unit circle, let's go ahead and label this radian as theta, and we're going to say theta is 1 radian. So you can see, just like we label degrees in a circle, we can also start to label radians. That's just an alternative measurement to degrees. So radian is a way to measure an angle, an alternative to degrees. So what makes this angle right here 1 radian? 1 radian in a circle would be the angle which creates an arc length of 1. So by arc length refers to the piece of the circumference, or like if this was a pizza, the arc length would be like the crust of the pizza or the outside of the circle. And 1 radian is what's going to create an arc length equal to 1. So how do we actually calculate radians, convert back and forth between radians and degrees? We're going to be using these conversion factors, which you'll see in the example below how we actually apply those. And the conversion factors, if we're given degrees and we want to get to radians, the conversion factor is going to be pi over 180. And if we're given radians and we want to get to degrees, we're going to multiply by the inverse. So 180 over pi. These conversion factors are really important. I would put them on an index card, write them really big in your notebook. We're going to be coming back to these again and again throughout the rest of the year. You want to have these conversion factors memorized. So now, convert each of the following angles from radians to degrees or from degrees to radians. From radians to degrees or from degrees to radians. An angle measure is assumed to be in radians if the degree symbol is not indicated after it. So from now on, for the rest of your career in math, we're going to be practicing this a lot. Since radians are kind of what advanced mathematicians prefer to use over degrees, if you see a degree symbol, that's when you know that it's degrees. If you don't see any type of unit indicated, so just this 3 pi over 2 or this 1.4, these two are going to be assumed to be in radians because there's no degree symbol after. So let's just quickly label these. So in A, we're given degrees. In B, we're given radians. And in C, we're also given radians. And remember, radians are just another way to measure an angle, an alternative to degrees. So for A, I'm given degrees. And since I'm given degrees, I'm going to go ahead and convert this into radians. So let's go through A together. 30 degrees. I'm going to multiply, by my conversion factor. You can see here my conversion factor is pi over 180. So I'm going to take my degrees, I'm going to multiply by my conversion factor, pi over 180. And the results that I get, actually I'll just use the same symbol that we used in our conversion factor. So I'll use an arrow here. And the result that I get over here is going to be my radians. So I'm given degrees, I'm given the unit of degrees. I'm multiplying by my conversion factor, and I'm going to end up with my final answer in radian form. So I'm going to have to remember how to multiply fractions. Down here, if we have 30 degrees, I can rewrite that as 30 degrees over 1. It's the same thing. And then I'm going to keep this as pi over 180. And now that I have two fractions, I can just multiply directly across the top. So 30 times pi, I can also multiply directly across the bottom, 1 times 180. So multiplying the numerators, I get 30 pi at the top, and I'm just dropping that degree symbol because I'm about to be converting into radians. So I have 30 pi, and then on the bottom I have 180. That's my final answer. What I want to do now is simplify my final answer. So 30 pi over 180 is not in simplest form. What I'm going to start by doing is dividing the numerator and the denominator by a common factor. I can tell they're both divisible by 10. So then I'm going to get 3 pi over 18. And now I want to think, well, do 3 and 18 have a common factor? I know 18 divided by 3 is going to be 6. So I can divide the top and the bottom both by 3. And then I get my final simplified answer to be pi over 6. So I ended up with my final answer in radians, which was my goal. Okay, so go ahead and try B on your own. I encourage you to pause this video and then just come back and check. If you'd like to see B and C walked through step by step, then keep watching the video. Okay, so for B, I am given radians and I'm going to be converting into degrees. So I have 3 pi over 2. I'm going to be multiplying by my conversion factor. Keep going with the same system as before. Be multiplying by my conversion factor, and I'm going to end up with some measurement in. So this radians to degree, my second conversion. And then same thing, I'm going to be multiplying across the bottom and across the top. So let's go down to just the second line of the problem. So I'm going to be doing 3 pi over 2 times 180 over pi. When I multiply across the top, 3 times 180 is going to be, I'm checking my calculator, 3 times 180.
Are you still recording, Ms. Gitzel?
Yes, is 540. So I'm going to get 540 pi over 2 pi. And then it looks like both the top and the bottom are divisible by 2. So I'm going to end up getting 270 pi, I believe. Yes, 270 pi over pi. And then you'll notice that since I have a pi in both the top and the bottom, I can just actually cancel those out. Another way to think of this is you're just dividing by another common factor, which is pi. So I'm going to divide the top by pi and the bottom by pi. 270 pi divided by pi is just going to be 270. And then pi divided by pi is 1. So I'm going to get my final answer of 270 degrees. And in this case, because my final answer is in degrees, I need to make sure I include that unit, that degree symbol, so that I can tell what is a radian, what is a degree. because from now on we're never sure if an angle we're working with is a radian or a degree, unless we include that unit of degree, in which case we can always tell. All right, let's do C as the last one. Again, if you're still watching this, I encourage you to be pausing the video and trying these on your own before you watch the explanation. And then for C, I'm given war. So it's going to be in radians. I'm going to be multiplying by my conversion factor. So I start with radians, I'm multiplying by my conversion factor, and I'm going to get up to degrees. In this case, because I'm going from radians to degrees, my conversion factor is 180 over pi. And then I'm going to do 1.4 over 1 times 180 over pi. I'm rewriting this 1.4 as a fraction 1.4 over 1 so that I can then just multiply across the numerator and the denominator to get the answer. 1.4 times 180, can't do that in my head, 1.4 times 180 is 252. 1 times pi is pi, and then there are no common factors between the top and the bottom, so I'm going to go ahead and just divide this out, 252 divided by pi, in my calculator. Divided by is going to be 80.21. So that was a weird one. We start off with 1.4 radians, we're going to get to 81. And that's my final answer. All right, so maybe you can start to see some patterns between the radian measure and the degree measure. What I would like you to do now is work all three. You're going to be going through and labeling common angles on the unit circle in degrees and then radians. Okay, thank you for watching. Hi.